All right, ninth graders, we are doing solving systems by graphing, and this is going to be on page 62 in your math binder. So let's start at the top here. We're going to do a little review. You are going to set up and solve a system of equations to solve this following problem. Megan is getting paid $3 per hour plus $25 in tips. Jaylon is getting paid $5 per hour plus $17 in tips. After how many hours of work will Megan and Jaylon be getting paid the same amount? And how much will they earn? So we are going to start by setting up a system of equations. They ask two questions here. The first question is, after how many hours of work? The second question, how much will they earn? So I'm going to let my two unknowns, x and y, represent x being the number of hours, and y will be total paid. Whenever you assign x and y, put them on your x and your y axis. So I will have hours along the x-axis and money. Oh, I should probably put that a little bit further out because there are not labels on this side yet. I want to leave enough space where I can write all my numbers. So I'm going to say money paid. Okay, so let's write our equations now. For Megan, let's use pink. For Megan, her equation, well, we want to add up how much she gets paid. And we know that Megan gets paid $3 per hour. So I'm going to say 3, and then our hours was x. So I've got 3x. And I also need to add on Megan's tips, which were plus $25. Now, all of that equals Megan's total pay. So I'm going to start this with y equals 3x plus 25. All right, now for Jaylon, we've got her total pay is $5 per hour. So we start with $5 per hour, 5x, plus $17 in tips. And now we can graph these things. Now they're both solved for y, which is super helpful. I'm going to start by labeling the y-axis. I am going to, let's see. Remember how on our graphs in the 7th and 8th grade, we did this little like squiggly line, which means that we're breaking the graph. We're going to skip some numbers. So I'm going to skip, and I'm going to list the second one as 16. The third one will be 17, then we've got 18. Notice I'm only writing every other number because this is going to get very crowded. So then we've got 20, 22, 24, 26, 28, 30, 32, 34, 36, and 38. All right, let's start with Megan's graph. Megan starts at $25 on the y-axis, and she's going up 3 spaces to the right 1 for her slope. Up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. All right, so Megan's graph is set. And then for Jaylon's graph, we start at 17 and going up 1, 2, 3, 4, 5 to the right 1. 1, 2, 3, 4, 5 to the right 1. 1, 2, 3, 4, 5 to the right 1. 1, 2, 3, 4, 5 to the right 1. And you can see that we have the same exact dot at the very end there. Okay, so where do these cross? These cross at the ordered pair 4, 37. 4, 37. Okay, so that ordered pair, 4, 37, what does that mean in the context of this problem? Well, the x number is 4. That means that there were 4 hours. So I'm going to say in 4 hours, and then the 37 was money. So I'm going to say both made $37. And there we have it. So we can graph it, we can find where they cross, and put things back in the context of the story. All right, so let's go to fill in these blanks. One way to find the solution to a system of equations is to graph. the two equations and find out where the lines intersect. It's a fancy word for cross. Okay, so let's graph this number 1. On number 1, I'll begin by putting my first dot, let me let this zoom in, at +5. Then the slope is -1. I can make that -1 over +1. You're going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, and fill in the dots that you can. Now this is not a story problem. I'm going to have arrows going in both directions. And then I can graph the second one. My first dot goes at -3 and my slope is 1 over 1. So I'm going up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, back to the center. I can go down 1 to the left 1. Okay, there we go. And the ordered pair where these two lines cross is to the right 4, up 1. So my solution for 1. All right, I want you to look at number 2. I know you can get that first equation graphed. So put your first dot at 1, and then you're graphing up 3 to the right 1. Get that thing graphed. Okay, so how do you graph the second equation? It's a beautiful equation, but I can't graph it the way that it's written right now because it's not in slope-intercept form. So I need to solve that second equation for y. And I'm going to write a little note to myself. Solve for y. Okay, so when I solve for y here, I can start by adding 2x to both sides of this equation. And I have y equals 2x minus 1. So I can put my first dot at -1. And 2x is telling me to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Then I can go down 2 to the left 1, down 2 to the left 1. And these cross, these are very steep lines. They cross right here. That is at -2, -5 for my final solution. All right. You've got to solve 2 equations for number 3. So please push pause on your screen and I want you to try to solve and graph both of the equations on number 3. Okay, so I solved that second equation. I added x to both sides, divide by 3, divide by 3, divide by 3, and I have y equals 1/3 x, and then I changed this to a mixed number so I can find a better place to put it on the graph, minus 1 2/3. So let's see how you graph that. You go down 1 and then down 2/3. That's ridiculous and weird, but we're gonna do it. Okay, then we go up 1 to the right, 1, 2, 3. This is like a weird place. And then back to the middle, down 1 to the left, 1, 2, 3. Okay. I'm going to connect those dots. No, they are not perfect because I had to do like estimations, but you'll see where this goes. Okay, I'm going to solve this second equation. We had 3x plus 2y equals 4. I can subtract 3x from both sides, and I have 2y equals -3x plus 4. Divide by 2 everywhere, and y equals -3/2 x plus 2. So I put a dot at 2, down 3 to the right 2, down 3 to the right 2, up 3 to the left 2. Okay, these did not cross at one of my pretty little dots. And sometimes what I see people do when they get something like this is they write no solution. No solution should only be used in very different situations than this. And we'll actually talk about those situations on tomorrow's notes. This has a solution. These cross at this place. The question is, where is that place? Well, we can guess. I can guess that that's 2 to the right, down 1. So 2, -1. But how can I know for sure? Well, here's how you know for sure. Check it. So if I've got 2, -1, I'm going to check that by plugging it back into this original equation. Instead of 3x plus 2y equals 4, I'm going to have 3 times 2 plus 2 times negative 1 equals 4. Okay, 3 times 2 is 6. 2 times negative 1 is negative 2. Does 6 minus 2 equal 4? Yes. That first equation, it works. Okay, let's check the second equation now. I'm going to write check. So, I should say, we were guessing that they crossed at 2, negative 1. Okay, so now when I check the second equation, negative, and then I'm putting in my x value of 2, plus 3 times my y value that I guessed as negative 1 equals negative 5. We want to know, is that true? So, negative 2 plus negative 3 equals negative 5? Yeah, that does equal negative 5. So it worked for both. So that was not merely a check, it was actually the actual solution. Okay, let's go to the last one. I'm gonna let you, this shouldn't take you more than like a minute and a half. Push pause for a minute and a half. I want you to do problem number 4 and then we'll check it together. Okay, let's have you check your work. I'm gonna show you this one. I started by solving this equation for y. I subtracted x from both sides and I got negative y equals negative x minus 5. Don't forget that negative is in front of the y. You have to divide by negative 1 everywhere and you get y equals x minus 5. So I put my first dot at negative 5. I go up 1 to the right 1 and there's my pink line. Then I can do my second one. Well, it doesn't have anything added on the end, which means start at 0. I put my dot at 0. I go down 4 to the right 1. Bam, that's where they cross. Bam, there's my answer. 1, negative 4. All right, get working on the homework, 9th graders.